Okay, so like I said, this is just another way of graphing. Now, remember whenever we talked about function form at the beginning of this chapter, function form meant what? What had to be by itself? Y. Y had to be by itself. Okay, so when an equation is in function form, it's also in what we call slope-intercept form. Okay, slope-intercept form means this equation is written in a way where we can identify the slope, and we can also identify the y-intercept, where it crosses the y-axis. Okay, so the equation, and you'll get to know this equation, and you'll memorize it, and you'll know exactly what it's talking about. It's y equals mx plus b. So that's up here. Y equals mx plus b. Now the only two letters that we're going to talk about today, because we already know about y and x, is m and b. So we're going to learn what those two letters mean. The m, which is always going to be the number in front of x, the coefficient of x. Do you guys remember when we made a t-chart, how it was a pattern? And we could predict the pattern, and the pattern always matched the number in front of x, because that is the slope. That tells us the slope of the line. We talked about slope yesterday. That's how many points we rise and we run in order to graph a line, okay, or in between 2 points. It determines how steep it is, how flat it is, or straight up and down, right? Now, the b can be positive or negative, okay, but b refers to the y-intercept. It's the point where it crosses the y-axis. All right, so y equals mx plus b. Now, here's an actual equation. Y equals 4x plus 1. Now, the first part of the lesson is only going to ask you, label the slope, label the y-intercept. The slope is always the number in front of x. Okay, so what number is in front of x in this equation right here? 4. Okay, so this is the slope. So we would say this is the slope. Now, what does that tell us? Is the line positive or negative? Positive. Positive. Why? Because the number in front of x is positive, the slope. So we would actually, if we were using this to graph, we would write the slope as 4/1, meaning that in between each point, we would rise 4 and we would run 1. Okay? And we'll see that here in a second. Now the second number is the y-intercept. Okay? So this number right here is the y-intercept. It represents the point 0, 1. That's where we would start the line. We would put a dot right on the point 0, 1, and then from there we could draw the line by rising 4 and running 1, rising 4, running 1, rising 4, running 1, and you can do that indefinitely. Now the other way to do this would be make a t-chart. Make a t-chart and use 0, 1, and 2 and find 3 points and graph them. Or today, as we're going to talk about, you can graph it easy this way. Yes?
So there's no x involved in this one?
Yeah, there is. There is, because it has to have that x right there. So, and we can still substitute values, because whenever we plot this line, we start here, but when we rise 4 and run 1, that's going to take us to another point on the graph, and there will be an x and a y for both of those.
So what would it look like?
Well, that's coming up. That's coming up on the example. So, but for the first part of the lesson, the only thing that they want you to do is identify the You can't add 3x to -2 because one of them has a variable and the other one doesn't. So there's my equation. It's now in slope-intercept form. So the number in front of x is what? And what does that represent? The slope. So we would say the slope is 3. And what is the y-intercept? -2. Okay? So is that line positive or negative? Negative. The slope tells whether the line is positive or negative. And that's the number in front of x. So is the number in front of x positive or negative? Positive. So the line is positive. Now what about example A? Was the slope positive or negative? Negative. Negative. Okay? So this is the last page we're going to do, is the second page. Okay? So this teaches us how do we graph it without doing a t-chart? Or how do we graph it without using the intercepts? Okay? What we're going to do, the very first thing to do is figure out the y-intercept, which we already in the first page learned which one is the y-intercept. Which number up there is the y-intercept? 5. 5, which represents the point 0, 5. Which, does that make sense? If I replaced x with 0, what would y be? 5. What's 1/4 times 0? 0. What's 0 plus 5? 5. Okay, so does it make sense that the y-intercept is 5? And then that's at the point 0, 5? Yeah, because when you replace x with 0, y is 5. So I'm going to start at that point right there, which is 0, 5. Okay? I'm just going to put a dot there. Now, from there, I'm going to use the slope to graph. The top number represents, okay, so we have a fraction, 1/4 is the slope. So what does the numerator represent? When we were talking about the slope yesterday, okay, remember? Rise over run. Okay, the top number represents the vertical change, and the bottom number represents the horizontal change. Okay, so the top number is 1, and that means rise. And since it's positive, it means I'm going to go up. So I'm going to rise 1. Now what is the bottom number? 4, and that represents the horizontal change, and that means I'm going to run 1, 2, 3, 4. And there's my point. Now this graph isn't going to allow me to fit another point on there, but I'll show you. To do it, you can do it again. From this point, you would rise 1, and you would run 1, 2, 3, 4. Now does that look like a line? Yeah. So from there, you would just connect the dots. And you have your line. I mean, mine is a little crooked, but
How many times are you supposed to?
you can do it forever and ever. I only ask that you do 3 points. Okay? So the slope is 1/4, so we plot a second point by moving up 1 unit and right 4. And then we draw a line. So these next couple are going to give us the opportunity to do the same thing. So in number 1, before we do anything, let's label the slope and the y-intercept. So what is the slope of number 1? 4. Okay? So the slope is 4. Now how can I write that as a fraction? 4 over 1. Okay? So that's what I'm going to use for the slope. Now what is the y-intercept? 3, which represents the point 0, 3. Okay, so that's the first thing to do. Now the second thing to do is find the y-intercept, 0, 3, which is right here. Now we rise and run. How many points are we going to rise? 4. 1, 2, 3, 4. How many points are we going to run? 1. Okay, and I can't fit another point on there, so I'll just go ahead and connect these 2 dots right here. Okay, and we could do this also, we could use a t-chart. And the first point, if we use 0, would be 0, 3. Okay? And the next point would be 1, 7. So this is just a faster way of doing it without having to use the t-chart. Okay? So, is this line positive or negative?
That is positive.
Positive. Okay? Now, what, look at subtract one x from each side so that I can get y by itself. Again, I can't subtract these two right here because they're not like terms. This cancels, and I've got to bring down negative 1y equals 8 minus 1x. Am I done?
Yeah.
No, what do I have to do?
Divide by negative.
Divide by negative 1. When I do that, I get y equals, what is positive 8 divided by negative 1? Negative 8. Negative 1 divided by negative 1? Positive 1, x. Okay, so again, we could rewrite this so that it's in true slope-intercept form by doing just that right there. So these two are the same. Now from here, can I label my slope and my y-intercept? Okay, what is the slope? 1. How do we know that that's the slope? Because it's before the x. Can I write 1 as a fraction? 1 over 1. Okay, and what is the y-intercept? Negative 8, which represents the point 0, negative 8. So where would I start? 0, negative 8, which is right here. Now my slope is what? 1 over 1. So I'm going to rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise, run, rise, run. You can keep doing that forever. And what does that make? A line. Is it a positive line or a negative line? Positive. Okay, and it would go on forever and ever. what's 6 divided by 2? 3. Okay, now the next thing to do, what is the slope? 5/2, which means I'm going to rise 5 and run 2. Is it positive or negative? Positive. Okay, now what's my y-intercept?
3. Yeah, 3.
Yep, which represents the point 0, 3. So I'm going to start at 0, 3, and then I'm going to rise 5, 1, 2, 3, 4, 5, and I'm going to run 2, 1, 2. Now I can't really, that graph that they give me, I don't have room to put another point on there, but can I connect the dots? Yep. Keep going. Yeah. Okay, we're not going to do the last page, but I do want you to flip over to practice A, and I want to do 1 or 2 more examples with you. I want to do, I'm going to do number, I want to do number 12, I want to do number 14, and I want to do, number 17. Okay, so real fast, let me pull that up, and we'll do those together. There we go. Okay, so let's go down to here. And I'm going to have to kind of draw my own graph here because I don't have one to do. Okay. So, let's look at number, which one did I say? 12. Okay, 12. Let's look at 12. Let's identify the slope on number 12. What is the slope? Okay, what's the slope again? The number in front of x. What's the number in front of x? So yes, it's going to be -1/1. Now, does it matter where I assign the negative sign? Okay, I can assign it to the numerator or to the denominator. If I assign it to the numerator, that means instead of rising 1, I'm going to fall 1, and and then I still run to the right here. Okay, but I'm going to fall. Now, if I reverse it and I do this, I would still rise 1, but instead I would run to the left. Okay, run
Which
to
one
the
you want
left.
us to do it?
Both will help you. Both will help you kind of understand. Now, from there, the y-intercept is 2/3. It's really hard to find 2/3 on a graph. So let's just, instead of making this 2/3, let's just make it 2. Let's just make it 2, because it's really hard to graph. Yes. Well, no, because none of the other ones, none of the other ones that I can see are going to end up being that. The fraction in front, this is, as long as the fraction in front of x, that's fine. That's your rise and your run. It's hard to graph when your y-intercept is not a whole number. Okay, so I'm making that a whole number. So now my y-intercept is 2. Now, if I was going to graph that, that's what that one would look like. Okay, let's look at number 14. Is number 14 in slope-intercept form? Yes. Okay, what's the y-intercept? 0, 0. Okay, so for this one, I would start at 0, 0, and then what's my slope? 7 over 9. So I would rise 7, 1, 2, 3, 4, 5, 6, 7, and then I would run 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I mean, that's a big slope right there. And it is positive, yes. Okay, now on all these, it's the easiest. What's your y-intercept going to be here?
-7.
0, -7. Okay, make sure that you know that that's a -7 right there. Okay, and then let's do, I said number 17. Okay, is y by itself?
No.
No.
It's not in function form.
It's not in function form.
It is in function form.
I would have to add 2/5 x to each side. And that would give me y equals 2/5 x plus 0, right? So what's my y-intercept here?
0.
0, 0. What's my slope? 2 over 5. So I would start at 0, 0. I would rise 1, 2, run 5. 1, 2, 3, 4, 5. Then I would rise 2, run 1, 2, 3, 4, 5. And I have my line. Okay.
He's very little now.
Right, right. Is there another one up there? Let's see.
Which one?
Let's do number 15 real fast. I'll do that one. We'll do number 15. Okay? So I'm going to go ahead and draw my graph. And it's